Welcome to Simcast, a podcast brought to you by the Society for Imaging Informatics in Medicine.
Greetings, Simcast listeners. Today, we're talking to a number of guests about important topics in semantic interoperability, things like CDEs, Open Imaging Data Model, Imaging Problem List, and others as well. So let me introduce our guests. First, we have Dr. Michael Hood, who's an emergency radiologist at Massachusetts General Hospital, Harvard Medical School. He serves as the system-wide service chief for radiography across Mass General Brigham, where he leads enterprise initiatives in X-ray operations, quality, and standardization. His work focuses on imaging informatics, especially the development of structured data models. He's an active contributor to RSNA and SIM efforts that advance interoperability and clinical decision support in radiology. His current projects span ontology, design, deterministic information extraction, operational process reform, and the practical integration of new technologies into frontline emergency care. His goal is to improve accuracy, consistency, and equity in imaging interpretation and reporting. Second, we have Heather Chase, who is a senior engineer and clinical informaticist at Microsoft Newest Diagnostics R&D. With a focus on imaging informatics and AI-driven workflows, Heather works on integrating structured data models and large language models to enhance radiology reporting efficiency. As a SIM member and frequent contributor to SIM discussions, Heather is passionate about reducing cognitive load for clinicians and advancing interoperability standards in healthcare. Last but not least, we have Dr. Tariq Al-Kassab, who works as a board-certified diagnostic radiologist in the Division of Emergency Imaging in the Department of Radiology of the Massachusetts General Hospital, where he also serves as the medical director for Enterprise Informatics/IT. He is assistant professor of radiology at Harvard Medical School. He sits on the Informatics Commission at the American College of Radiology, co-chairs the joint ACR-RSNA Common Data Elements Committee, and is on the RSNA Reporting Informatics and RADLAS committees. His research focuses on applying information systems to improve workflow and quality in medical imaging. Dr. Al-Kassab completed his residency as well as fellowships in imaging informatics and abdominal imaging and intervention at Massachusetts General Hospital. He received his MD and PhD in neuroscience from Tufts University School of Medicine after completing his undergraduate work at the Massachusetts Institute of Technology. I hope you enjoy listening to our guests as much as I enjoy chatting with them on this episode. Thank you for listening. All right, welcome Simcast listeners. I'm sitting here with Tariq, Michael, and Heather. And I'd like to start with Tariq today. So Tariq, I know there are a lot of exciting developments in the open imaging data model world. Why don't you start us off with a quick recap?
Sure. Thanks, Mohammed. And it's great to be here for another conversation about this. I love talking about this stuff and really am excited to be able to share it with even more people. So there are basically two major thrusts right now of work in the Open Imaging Data Model project. One of them, which we'll go into a lot more detail about, I'm sure, is kind of fleshing out one of the major areas of the data model itself, which is being able to understand a patient's imaging history, being able to understand and represent the patient's prior imaging results. And that is a project we're calling the Imaging Problem List. And it fits into and has the potential to drive a lot of exciting kinds of projects and libraries and tools, and a lot of different vendor partners in the project have gotten engaged with that. And it's really starting to take shape in an exciting way. So that's one big thrust where we're putting together structures for making it easy to understand what's happened in the past with a patient as the basis for all kinds of forward-looking tools. And then the other piece is that we've gotten some real traction on being able to create the set of labels that we use for those. So I know many of the listeners have heard about the ACR RSNA Common Data Element project, And this is kind of an extension and support for that, where we have these things that we call open imaging finding models, which are intended to be basically these drafts of what, could eventually go through the ACR RSNA process, but first are kind of just provide, standard consistent labels, which is kind of the major applications for CDEs for a huge number of potential things that people see on imaging exams. And obviously that is really important for supporting the imaging problem list project. And so it just sort of creates a more nimble feeder process for kind of the heavier weight common data element process as it exists, but it enables us to power these applications based on the imaging problem list that need to have the appropriate semantics to understand what's happened in the past with a patient's imaging.
That's wonderful. And I remember, as someone who managed to make it to your session at SIM this past year, that you have also done a lot of homework when it comes to this. So I do want to turn it to Michael first, because I know you also had some interesting ideas about how the imaging problem list could be created. And then afterwards, Heather, I'd love to hear from you about the work you've done in this regard as well.
I think one of the ideas, it's hard to conceptualize what this is. And so I would say traditional radiology is like taking 50 pictures of your kids and putting every photo in a different folder in your house. And what I would say the imaging problem list is like the concept of photo tagging on Facebook, for example. It knows it's the same kid across all 50 photos and shows you their timeline. And so the imaging problem list represents this idea of longitudinal tracking of persistent clinical entities over time. And that opens up a lot of value propositions, several of which we can talk about. But one, for example, right at the top is chronic disease management. So let's say a patient has an abdominal aortic aneurysm, and radiologists are really good at tracking what happened to the immediate last prior, right? We compare to the immediate prior and sometimes multiple priors, but it would be nice if this were all automated. And so what if for every, let's say a patient has 10 CT scans that are tracking abdominal aortic aneurysm, you could have this imaging problem list essentially represent, here's the growth at time A and time B and time C. And so instead of having these siloed reports that you're having to manually cross compare, you now have an entity that is capturing all of that and showing it to you longitudinally. There's so many other options too. So like another example would be patients who have had certain surgeries, so like post-operative monitoring. One of the challenges that we have as radiologists is you get a scan and you see like post-surgical changes of stuff, but you don't know necessarily why it was done or what specifically was done. So it would be nice to automatically track those things that are not going to change over time. So things like chronic findings like a cholecystectomy has occurred, appendectomy, or things like, things that you would not expect to change. So like an old fracture that's now healed, or, a calcified granuloma that's always going to look the same. There's this idea that every time we open an exam, you're going to spend a few minutes categorizing all of the chronic findings that the patient will have on every exam forever after. Think how many minutes you would save every time if you had some device or tool that could automatically have those categorized and even put them in for you. So there's a lot of time savings on the radiologist side for something like this.
100%. I actually have a friend who used to joke that sometimes it's faster for him to read the prior scan than it was to try and read the report. So I totally sympathize with what you're saying. That being said, for the record, being an unclinical person, I always get a kick out of reading my own reports just because, to a layman, I love the very dry scientific language that radiologists use. So I remember one of my reports where my pancreas was described as unremarkable, which was slightly offending, but I understand that's good news. So
I'm sure your pancreas is spectacular, Mohammed.
thank you. I feel reassured.
At least it wasn't your brain that they were remarking on.
Oh, that one was completely missing.
Oh, no.
Heather, I want to hear about your work in this area.
Sure. So from a Microsoft standpoint, we're very interested in this as well. I think any company out there right now that's working within the radiological community is interested in what we're doing. And that is the OIDM framework, having these models that you can create pretty easily using a product called the Finding Model Forge, which was actually how this kind of all spun off. Was several years ago, I came on with Tarek, and we were trying to make CDEs as fast as we could. And for a human, it just doesn't compute. It's not scalable. So we put our heads together, and Tarek coded pretty much everything himself. And we came up with this really cool model that spits out our actual OIDM framework. And so any kind of finding that you're trying to create is very simple to do. You can actually, anybody can go. It's open source. Microsoft supports anything that is open source. And so we are excited to see how this takes off. It's always such an honor to work with these gentlemen. So yeah, it's been a pleasure. Coming up with this ontology with Tarek has been, how do you describe it really? It's been fast and furious, but then it's been, slow and painful. And I've only been on board for 3 or 4 years. And Tarek, you've been doing this work for a decade?
About that, yeah. Pretty close now.
Yeah. So we're pretty excited about where it's headed and what it can do, specifically feeding into things like the Empower application, lots that can be done there. And just really, if you think about tracking these studies and what that can produce, I'm really excited at the idea that it could really make a difference in better patient outcomes.
Exactly. Like the efficiency of, instead of you dictating status post cholecystectomy, splenectomy, right nephrectomy, old rib fractures. I mean, you're spending so much time dictating those old findings, and, you'd save minutes over the course of every day not having to do that. So think how much time you would save with something like this.
And it's, I think, to me, even better because it's not just the time, but it's kind of taking the radiologist's mental bandwidth and taking it away from what amounts basically to bookkeeping, right? Like, oh, we just transfer this over, transfer that over, transfer that over, and lets them put more of their energy into the important stuff of figuring out what's really going on, right? Like, what are the actual questions here and how do we most usefully answer them?
Well, I think that, when you think about putting AI into healthcare, I think our number one concern is accuracy and that we can control hallucinations. And I think that this is your healthcare approach. Your medical approach is going to be to have these codes associated so that the semantics come out right. Think like a radiologist. Well, if you have these codes on the different findings, the semantics will come. And then you have a way to double check if needed, instead of it being that you have to read through every single report. That doesn't speed anybody up.
Right. Like one of the questions that often comes up is why not just throw reports into ChatGPT or, an LLM and have it spit out all the findings back? And the answer is right now, it just doesn't do it accurately enough. And it's not replicatable or replicable. And, you ask it to do the same task 2-3 times, it'll do it differently each time. And so the value of creating these finding models or these common data elements is to essentially provide a scaffold so that the LLM is not just free-form guessing how to parse this report out. You're essentially giving it a rubric to fill out instead, which it's much more capable and reliable of doing.
Yeah, and then you'll have the same result no matter how many times you submit it.
Exactly.
And the imaging problem list is a way of making sure that that information is captured so that, you only do it, the one time, and then it's already represented in that handy, portable, easy to work with format forevermore, right? Regardless of whether you're using it to drive kind of deterministic programs, like, something that just, if you wanted to write a code that was looking for, the presence of pacemakers on patients who are having an MRI tomorrow, right? Like you can do a search for that now. in a way that would be much harder if you had to try and, generate natural language searches for, mentions of pacemakers. But then also you can use it to really create really tight, effective context for LLM-based applications. And, one of the things we learn in engineering actual systems with LLMs is that really having careful control of the context is kind of the difference between really effective systems and systems that are pretty good, but sometimes make really embarrassing mistakes.
Yeah, I'm pretty good in healthcare. I just don't think there's a place for that anymore. So off with that.
I think the downstream usage of something like this also would be very helpful. So one area that I like to think about is like research applications of something like this. If an organization had such stewardship over their data, like this, imagine I was giving this example recently of like a transplant dashboard. So like the liver transplant service wants to track all of their post-transplant patients and see like which one of them have bile duct strictures, how many stents they have, any vascular complications, rejections, etc. By imaging, that would be a lot of manual labor to categorize and monitor all that, but the imaging problem list would facilitate something like that. Another example might be urology that wants to know recurrent stone formers. And so you could see like the number and size of renal stones on a patient tracked over time, tracked over an entire clinic's worth of people. So the ability to study certain specific disease states at scale is enabled with this.
Well, I was thinking about, that really easy way for the system to not kind of catch on to how important something is and how we save face by putting these codes on here so that you're not, paging doctors in the middle of the night to say, hey, there's a, cranial hemorrhage. Oh, wait, never mind. This one's good. Shouldn't have called you. Sorry about that. Like, we just want to minimize those types of things too. I think we all know that radiology and imaging as a whole, that these providers are super, super overworked right now. They're getting a ton in, and then they have to prioritize their time to get all of that back out. And the last thing we want to do is take up any extra time. So what this will do is bypass all of the way I look at it is all the human, type errors that we make. Let's not leave it up to humans. Let's really codify all the findings so that when it is something that is critical, it's going to come across as critical, not just because it's a critical finding that is, doing well at the moment. So, yeah, it's very exciting.
100%. And I was going to say, I mean, the argument for coding findings, I think, propagates through more than just, being able to populate an imaging problem list. I remember for years, I've been telling people who don't understand the concept is like, you're not leaving room for guessing, no room for interpretation, not just from an LLM. But the reality is, even human beings, some people, for example, read something and if it says not, sometimes they miss the word not and just read it the opposite. Not too long ago, I was actually trying to meet up with a friend and he said, I'm available every day except Monday. And somehow I read this, I'm available on Monday. Humans are just like that.
Yes.
But once you have these definitive findings, think about all the machines downstream that also could trigger action based on this. And this is actually one of the things I wanted to ask you all about, because I also know that this is work that seems to be getting a lot of momentum, and I'm seeing a lot of alignment happening. For example, I know I've heard that in the context of IHE profile, so there's alignment happening with the imaging diagnostic report IHE profile. Obviously, Michael and Heather, you're both involved in the RSNA Radiology Reimagined demo, where there's some work happening. I'd love to hear about all these cool new things that we can look forward to.
Well, I can start with the one you were describing first, which is the IHE side, which is, I think, really exciting, the imaging diagnostic report as a way of representing results. So they've gone through an iteration starting with, trying to represent kind of the conclusions of reports. And we're working this year and trying to help them with that, with especially the findings section. And so we've come up with some standard best practices for using FHIR for representing radiology results, especially using common data element identifiers, or, in case of kind of the more speculative stuff, these new finding model identifiers, as ways of providing the semantics associated with that grammar being defined in the IHE world. So that I think we really are seeing now clearly the path to a radiology report consisting not just of the unstructured text that a radiologist speaks, but also probably a structured section which contains a list of the findings that the radiologist has described on that report at some level of detail. It may start with just a list of a finding and whether it's present or not, a finding and it's absent, a finding and it's reported as present, et cetera. That's kind of, a very low resolution data version of it, but still quite valuable. But I think eventually will evolve into, more sophisticated and even more useful descriptions of the findings in the report, encoded in a way that, they can drive all of these applications that we've been talking about.
I think that's the really important thing, is that, this is just the underneath. This is kind of the behind the scenes stuff that all of our other agentic framework is going to utilize to run. And if you think about what agentic framework really is, I mean, each is their own little thing. And so there can be tons of them, many, many, many dozens, that take this information and travel it in different ways to output different things. And I think that this is just the beginning.
Exactly. One of the kind of use cases that we're showing off in the Radiology Reimagined demo is combining the concept of opportunistic screening and how this can play into it. So imagine you have a patient who's presented to the ED, for unrelated complaint, let's say stones. And so they get a CT scan. Let's say you have imaging or pixel AI that is capable at looking at certain features that are not related to the point of the scan. So things that are present, like the patient's visceral and abdominal fat, their muscle density, their bone density, the presence of certain vascular calcifications, like on coronary arteries. These are all things that may not inform like the current, today's treatment, but are important for the patient's health over time. And so by incorporating in this demo the pixel AI and the common data elements that then feed into this longitudinal problem list, you can create an entity that basically feeds forward into the patient's chart. So that way, when the patient's PCP opens up their health record, they see a notification saying, oh, coronary artery calcifications was noted on the prior. This patient should get a statin or a cardiology follow-up and things like that. So the ability to inform or capture patients into a treatment funnel. Another example might be if they have osteoporosis, this patient would benefit from a DEXA scan. Or a patient has other incidental like they've got an adrenal nodule, or they have a pancreatic cyst, or a cyst in their adnexa after menopause. These are all things that would need follow-up afterwards. And so this can help to both categorize it so it doesn't fall through the cracks and stimulate the follow-up action. All right. So a call to action to our listeners. The imaging problem list transforms radiology from a collection of reports into an actual clinical knowledge system. And what's exciting, I think, especially is this buildable right now? We're working on the extraction architecture, the data models are being built, and I think the clinical value is really clear in building something like this. What we need is now more engagement with the idea and commitment from institutions to actually build and develop the infrastructure. These are all things that the technology is ready, and so we should be working on this right now. Why isn't this exist yet is what a lot of people tell me when I talk to about.
Yeah, and I, want to stress that call to action and just say that, this is your industry too. Come and talk to us about what you want to see in your models. You can reach out to Tarek, to Michael, or myself, and we can give you a full demo on how we do this in about 15 minutes flat. So get out there and look at the finding model forage, look at the GitHub. That's where our repo is. Like I said, it's open source, and it's a call to action. let's make a difference here. Let's get these codes finished.
I'll tell you that actually you don't even need to reach out to us. If you're a misanthrope like me and you don't want to talk to anybody, you can just go to the Finding Model Forge site, and there's a button right on the homepage that we're going to be debuting at RSNA that will let you put in a suggestion for a new finding model, and you'll get feedback when your suggestion gets incorporated into the system. But you also have an opportunity, without emailing anyone specific, to look at the existing models, comment on them, suggest improvements to them, and then hear about how your suggestions end up getting incorporated into the knowledge of the repository.
One thing is for sure is that we never have a shortage of words to convey our excitement over this project. So please come talk to us. I know, Tarek, you represented the ones that don't want to talk, but anybody wants to talk, come on. Because
Absolutely.
the more we talk, the more we come up with, and the more fun it becomes.
I send those people to Michael and Heather.
Yes.
Nice. I like how you've got this all figured out. I'll also just add to what you're saying in your call to action. Like any other initiative project, the reality is everyone, I think, in this case, has a role to play, regardless of what walk of your life it is. So whether you're clinical or technical or something in between, I feel like everyone can contribute here. So definitely, don't be discouraged if let's say you're clinical and you're not really in possession of any development skills. When you hear words like GitHub or a repo or anything like that, there's still room for everyone to contribute here.
That is the point of the Forge, actually, is to take kind of, we're running the whole thing on a GitHub repository, but the Forge site is intended to be a place where anyone can interact with them. And in fact, if you tell it, about a finding, it will take what you tell it just as, your thoughts or notes on something, or even just the name of a finding. And we've set up some really cool AI-based tools that will actually turn that into, real code in the background that you don't even have to look at if you don't want to, but will tell you what it's actually doing and how it would work and how it would fit into systems. And you'd be able to really contribute kind of to this real, very important base level infrastructure of our coming world.
That's awesome. I think maybe the only thing left at this point is just gamify it and have like a leaderboard. Inject a little competition.
That is an awesome idea. I'm going to figure out.
Michael's winning, by the way.
ISO is for sure winning.
Nice.
I will say that, right now we have a lot of the content comes from Chuck Kahn's Gamuts project, which has to be acknowledged as kind of one of the real forerunners of this entire concept. And so I think actually, if you give Chuck credit for those, I think Chuck is probably ahead of everybody, as he is in so many other regards. So thanks to Chuck, as always.
All right, that's awesome. Unfortunately, we are running out of time. So with that being said, I'd love to go run the virtual table here and just ask all of you for your closing thoughts. Maybe let's start in reverse order this time. Maybe we'll start with you, Heather.
Okay. So I guess my final thoughts would be, it's not going to move unless we all come together and move it forward. It really does deserve everybody's attention so that we don't have to worry about how long LLMs take to become foolproof, if that is even a thing. I think that having these guardrails on just makes sense. It's healthcare. We don't risk healthcare. We don't risk that documentation. And so if this is a way to prevent risk, I think it makes total sense. And then building off of it, it just seems like it's left to the imagination what all we could do with this. There's so many different other technologies down the line that can utilize it. It just is a win-win. Once we get past this part of getting it all built out, then it's just there and we just keep moving forward.
Michael?
I would say that my closer, the imaging problem list turns radiology from being a report-centric entity to entity-specific. So you're making it about the findings and how they change over time. And developing a system that lets you track those entities creates incredible efficiency and quality gains, both for radiologists and clinicians. And I think what is most exciting about it is that this is no longer just a moonshot, right? This has been like a informatics holy grail for some time. But now we have the ability to do it. It's not science fiction anymore. And so now the hard work begins of actually building out the data structures to capture the findings. That's where we are right now. But the potential value of something like this is incredible. And that's what drives me and what I hope other people can see and get excited about.
And I'll just close with, I think we're on the verge of making being a radiologist more fun than it has been. I think we're heading toward a really cool future where we both get to do better and have a more gratifying, rewarding experience doing it. And I can't wait to practice radiology in the world that I'm getting to help build with, well, frankly, it feels like just a big club of my friends.
That's awesome. Thank you all very much.
Simcast has been brought to you by the Society of Imaging Informatics in Medicine. Please visit our website at siim.org for more information and educational content, including webinars and an archive of prior episodes. Please follow us on Twitter at sim_tweets. Thank you to our listeners for your continued support.